So as we are discussing the reaction of nitrines, so this is the last and final reaction of the nitrines, which is called rearrangement reactions. So this is the first rearrangement, which is called Hofmann rearrangement. Basically, Hofmann rearrangement, the starting material for the Hofmann rearrangement is this primary amide. This primary amide, and the conditions for this Hofmann rearrangement is sodium hydroxide and bromine. So this primary amine is converted into this primary amide is converted into amine. So this is the Hofmann rearrangement. So let's discuss in detail this Hofmann rearrangement. This primary amine reacts with in the presence of the base. It forms this enolate. Then this enolate reacts with this base, takes the proton here to form this enolate. This enolate acts as a nucleophile, then it reacts with this bromine, and this take this bromine electrophile, and this bromide ion is removed. So it forms N-bromo amide derivative. Then this N-bromo amide derivative, again the base takes this proton from here, and then this negative charge, when it comes back, and this beer leaves to generate acyl nitrene. So this acyl nitrene is an intermediate. It undergo the rearrangement. Though this this acyl nitrene rearranged to form this isocyanate. This isocyanate, now it can react in three ways. If the solvent is water here, then with the loss of this water reacts with isocyanate. With the loss of carbon dioxide molecule, it form amine derivative. So if this if any alcohol is a solvent like methanol or ethanol, then this alcohol reacts with this isocyanate to form the carbamate or urethane derivative. Carbamate or urethane, carbamate is also called the urethane. In carbamate, there on the one side you can see this amide functionality, and the other side you can see an ester functionality. So these are the carbamate or urethane. They are very important synthetic materials. So this, if isocyanate reacts with amine, primary amine, then this form this urea derivative. So depending on the which solvent is used, we can make we can convert this isocyanate into amine, into carbamate or urethane, and we can also convert, if amine is reacts with this isocyanate, we can form the urea derivative. So this is overall, this is called the Hofmann rearrangement, which we can summarize it that in the presence of this strong inorganic base sodium hydroxide and bromine, this primary amide converted to amine, carbamate and urea derivative. So we can form all the three types of these derivatives depending on how the isocyanate reacts. So as we are discussing the reactions of nitrene, these are the rearrangement reaction. So we will discuss about the Curtius rearrangement. Curtius rearrangement is also very similar to Hofmann rearrangement, but here the starting materials which is used for the Curtius rearrangement is different. Here we starting from the carboxylic acid. Carboxylic acid is reacts with thionyl chloride to form this acid chloride derivative. This acid chloride then reacts with sodium azide to form this acyl azide derivative. So this acyl azide, when nitrogen is eliminated, this undergoes thermolysis in the presence of heat. Its nitrogen is eliminated, it forms this acyl nitrene. So this acyl nitrene is undergo rearrangement to form this isocyanate. This isocyanate, when reacts with water molecule, this lone pair attacks on this carbon, and then this 2 electrons shifted on nitrogen. So this proton from water is shifted to on this nitrogen, and then this carbon dioxide is eliminated to form this amine derivative. So this amine derivative is produced after the loss of the carbon dioxide. So when if isocyanate reacts with alcohol, it forms the carbamate. Carbamate is also called urethane, and when and when this reacts with amine, this isocyanate, it forms the urea derivatives. These are all almost similar to the Hofmann rearrangement, production of amine, carbamate and urea, but difference is between the Hofmann rearrangement and the Curtius rearrangement is the starting material. The starting material used in the Hofmann rearrangement is primary amide, and here in this case this we start from the carboxylic acid, and then carboxylic acid is converted into acyl chloride by the reaction of thionyl chloride, and then this acyl chloride is converted into acyl azide in the by reacting with sodium azide, and with the loss of this nitrogen it generates through alpha elimination this acyl nitrene. So as we are discussing the reaction of nitrines, here we will discuss about the another rearrangement which is called Lossen rearrangement, and in this Lossen rearrangement this starting material is again acyl chloride, carboxylic acid. Carboxylic acid is converted to acyl chloride by reaction with thionyl chloride, and then this acyl chloride reacts with hydroxylamine with the elimination of the hydrochloric acid to form this starting material. This OH is protected with this acyl chloride to acetate here, and then this is called hydroxamate derivative. This hydroxamate derivative is then reacts with sodium hydroxide, which takes this proton, and with the elimination of this acetate through alpha elimination at this nitrogen atom, with the base takes this proton, and the elimination of this acetate generates the acyl nitrene. Then this acyl nitrene is converted into, undergoes rearrangement to form this isocyanate. Isocyanate then reacts with water molecule to form this with the elimination of carbon dioxide form this amine derivative. So if isocyanate, if we use the alcohol as a solvent, then this isocyanate reacts with this alcohol to form the carbamate or urethane derivative. And if we are using any amine as a solvent, then this reacts with this amine isocyanate, it forms a urea derivative. So this is a whole this whole reaction is called Lossen rearrangement. Through this hydroxamate derivative we get this isocyanate through acyl nitrene as an intermediate. So this is the last and final rearrangement, which is called Schmidt rearrangement. In this Schmidt rearrangement, we again starting from the carboxylic acid. Carboxylic acid in the presence of mineral acid, it's protonated, and then this is the protonated form of the carboxylic acid. Then it reacts with the hydrazoic acid. Hydrazoic acid, this lone pair of nitrogen attacks on this carbon, and this water is eliminated, and also this proton on the hydrazoic acid is also eliminated to yield this acyl azide. This acyl azide, then this is the resonance form of the acyl azide. If we simply do this, then we will get this. This is the same acyl azide. This second resonance form of acyl azide. Then the elimination of the nitrogen molecule, it generates this acyl nitrene. This acyl nitrene then undergoes rearrangement to form this isocyanate, and then this again the same cases. If isocyanate reacts with water, it forms the amine derivative with loss of carbon dioxide molecule. If this isocyanate reacts with the primary amine, we will get the urea derivative, and if this isocyanate reacts with the alcohol, it will form the carbamate or urethane derivative. So this is the Schmidt rearrangement. So all these rearrangements, Hofmann, Curtius, Schmidt and Lossen, they all generates this acyl nitrene, but the starting material is different. So you see this Schmidt rearrangement, we make this acyl azide from the hydrozoic acid. In the Hofmann we use the primary amide. In the Curtius rearrangement we again make this acyl azide, but with the acyl azide is generated from the acyl chloride and sodium azide reaction. We generate this acyl azide, and in the Schmidt rearrangement carboxylic acid reacts with the hydroxylamine, and then this hydroxylamine is protected with the acetate moiety to convert the OH into good living group, and then this again rearrange to form this nitrene. So all these four rearrangements we make this acyl nitrene, and then this acyl nitrate rearranged to form isocyanate, and then this isocyanate is converted into amine, carbamate or urethane or urea derivatives. So this is the summary of all these four rearrangements.